Hello everybody, welcome to day 3 of Credit 10, Solutions. So, talking about different solutions for the quadratic form through to quadratic equations by using the quadratic formula. So, go ahead and answer these. These are kind of just questions to help you understand how the quadratic formula works. So, let's just again write that up here. Okay, so maybe every quadratic equation has two solutions. Is that, do you agree with that or disagree with that? So maybe state your reasons why, looking at that, the quadratic formula can be applied to an equation like this. Do you agree or disagree that it could be applied to something like this? Um, so maybe that's the same one. So if you were to solve it, would you set a equal to -7, b equal to 8, and c equal to 1? Agree or disagree, and your question and your answer why, and so on. Okay. Now irrational solutions. So irrational solutions happen when you can't actually take the square root of something. So the square root of 9060 in this case is 95.18, and it's irrational, so it doesn't repeat or anything like that. So it gives you this kind of approximation. And then 45/16 is a rational number, so it has a terminating decimal. And then when you take that number minus this number, which is approximate, then you get this answer, or when you subtract it, you get this answer. Or wait, this is when you subtract it, so it's minus a minus, so it makes it a plus. So you get these two as your solutions. So how do engineers and scientists get answers then? You guessed it, by fancy calculators and specialized computer software, right? As an engineer, all I did was I would just program the quadratic formula into the computer, and then it would spit me out a approximation like this. And very rarely did I ever use an irrational number in kind of this form, right? 5 plus square root of 2. I very rarely ever use something like that. I would just go to my calculator and say, okay, what's the square root of 2? And I'm going to add 5 to it. So I would use something like this, that 6.414, and usually that's a good enough approximation for designing a bridge or something like that. Okay, so the square root of the discriminant, by the way, this word discriminant is talking about this part under the radical, the b squared minus 4ac. So with that, so if you can find out what the discriminant is, so if it has a perfect square, it will be rational. If it has no perfect square, like this case, square root of 33 is irrational, so the type of solution will be irrational. So whatever's under the square root, if it's a rational number, then you'll have rational solutions. If it's irrational, you will have irrational solutions. Okay, and here's just some more practice on using the quadratic formula. So what you want to do is rearrange these so that you get them in the form ax squared plus bx plus c. So you will have to move the x squared over, so this would be x squared plus 5x minus 3 equals 0. So now it's in that form. So my a value is the coefficient on x squared, which in this case is a 1 because that's the multiplier, 1 times x squared. B is 5 and c is -3. Okay, so I'm going to use these coefficients in the quadratic formula to find my x values that would make this statement true. So I have negative b plus or minus the square root of b squared, so 5 squared is 25, minus 4 times a times c, which is -3, over 2a, so 2 times 1, which is 2. Okay, so 25 minus, and this is minus and minus, so this is going to be a positive 12, so 25 plus 12. is 37. So it's the square root of 37. So my answer is going to be negative 5 plus or minus the square root of 37 over 2. So at this point, I just go to the calculator. My computer's slow. Okay. Negative 5 plus the square root of 37. And then that divided by 2. And the other one would be minus the square root of 37. And that divided by 2. So my two options are 0.541, and my other one is negative 5.541. Okay, so those are my two solutions, and that's how you would do those problems there. Okay, one solution only. So if x squared is equal to 0, if you square root both sides, you get x equals plus or minus 0. No, there's no plus or minus 0, it's just 0. So there's only one solution to this. And anytime you have a perfect square equal to 0, there's only one solution. So how many solutions did you find? Okay, yeah, so I already gave you the answer, but see what happens when you graph that. So we were talking about how the solutions to setting a function equal to 0 is the x-intercept. So what happens, what does the x-intercept look like if there's only one solution? So go ahead and graph this function right there. Sometimes there's no solution, right? So if the so calculate the discriminant of the quadratic formula for the quadratic equation here. Alright, so we need to set it equal to 0, so I'm going to add 4 to both sides, so I get 29. And then my A, B, and C are 1, 10, and 29. So what is b squared minus 4ac? So 10 squared is 100 minus 4 times 1 times 29. Okay, so what do you get there? And when you take the square root of this number, what happens? Yeah, what is the square root of negative 16? Let's look at a graph of the square root function. So negative 16 for x. See, there are no negative square roots. The graph only exists from 0 to the right. Okay, so if you calculate the discriminant for the quadratic equation for these different problems, you should be able to tell me if there's going to be one solution, no solution, or two solutions. So rearrange that, find out what the square root is. So that b squared minus 4ac, this is called the discriminant because, you know, like the word discriminate, it means you tell the difference between things, right? Or if you discriminate against a certain race or something, you're like objectifying that they are different, right? So discriminant means that this is how we tell the difference between different solutions, right? How many solutions are there? So if the value here is greater than 0, it's a positive number, there's two solutions. If the value here is 0, then there's one solution. And if the value is negative, there is no solutions, right? So that's how you use that discriminant. And that's it.